In this problem, factor the polynomial function f of x, then solve the equation f of x is equal to 0. So f of x equals x cubed plus 10x squared plus 17x minus 28. Factoring, we don't have any problem when we have squared or a quadratic equation, or a quadratic function, because we can factor it using many methods. But when you have higher than second degree, sometimes it's hard to do it by grouping even. So we think about using different technique, okay? So recall something. Recall the rational zeros theorem. Rational zeros theorem. What does the rational zeros theorem say? It says, let p of x equals an x to the power of n, an minus 1, x to the power n minus 1, plus up to a1x plus a0. And all coefficients, this is very important, all coefficients are integers, whole numbers, positive or negative. Then what we're going to do is consider irrational number which is p over q. What is p? What is q? P is, or p and q first, p and q are relatively prime. What does this mean? There is no common factor between p and q, okay? So you cannot say p is 3, q is 6. No, this is not gonna be happening, okay? The only factor is gonna be only 1 and negative 1. So if p and q over q is a 0 of the function p of x, then p is a factor of a naught. P has to be a factor of a naught. This is a naught. And what? And q is going to be a factor of an. And q is a factor of an. So if you don't understand what's happening here, I'm going to explain it in the example. So in the example, now we are going to do factoring, right? To do factoring, you are going to check two things. A naught, which is negative 28, and we're going to check an. An, what is an in this case? An is the coefficient of the leading term, which is the leading coefficient, which is 1, which is what? 1. So what is an? It's not an, it's a3 now. a3 is 1, and a naught is negative 28. So this is p, and this is q. Okay? So a3 is going, or the coefficient of the leading term, which is the leading coefficient, is going to be q, and p is going to be the constant term. Then what we are going to do, we are going to find all of the possibilities now. For p. We will divide them by the possibilities for q. What are the possibilities? The factors. What are the factors of p? All of the factors of p. The divisors of p. The p is negative 28. So just ask yourself, 28 is, is divisible by what? It's divisible by 1, by 2, right? By 7, right? By 4. So just try it all of the factors. 1 plus or minus, 2 plus or minus, 4 plus or minus, then we got 7. What else? 28 plus or minus, and we have 14 plus or minus, and 28 plus or minus. All of these are divisors of the 28. What about the Q? The Q, we have only 1, so plus or minus 1. So what is the possibilities now? What are the possibilities? All the possibilities of possibilities for P over Q. Either you're going to have 1 over 1, or positive 1 over positive 1, or negative 1 over positive over negative 1, and so on. So I mean 1 over 1, you're going to have only 1, positive or negative. 2 over 1, you're going to have positive or negative. 4 over 1, positive or negative. And you have all these factors. All of these what? Factors. Possible factors. Possible factors. Then you're going to try now to pick one of these factors and perform the synthetic division to check whether these are zeros of f of x or no. How do we know this? By getting 0 in the remainder. So I'm going to now to start performing what? The division. So let's try the first one, number 1. So I'm going to try the first 1, okay, the first factor, number 1. Is it going to be a 0 of the function or no? So the synthetic division says, where is it? Okay, we have 1, 10, 17. So we have 1, 10, 17, and negative 28. Then I'm going to try to do the first 0, which is number 1. Is it a 0 or no? We don't know. So bring down 1, so we know how to do the synthetic division. Refer to the previous video. So this is 1. Then 1 times 1 is 1. Then add these two guys, you get 11. 11 times 1 is 11. Add these two guys, you get 28. 28 times 1 is 28. Then you add these two guys, we got 0. Luckily, we are, because we got 0 from the first trial. Okay? So good. Now, so what we know about this? So what is f of x? F of x is x cubed plus 10x squared plus 17x minus 28. And this can be written as what? The divisor times the quotient. The divisor is x minus 1 times the quotient is here. This is the quotient, which is x squared plus 11x minus positive 28. Plus the remainder. This is the remainder, which is 0. Because it's 0, you don't need to write it, okay? Because we got 0 already, so the 1 is 0, x minus 1 is a factor, so there is no meaning of writing the 0 here. So this is times, not minus, okay? The divisor is x minus 1, or let me do something. There's something we call what? The factor theorem. Factor theorem. What did we find? We found that the 1 is a 0 of the function. Is a 0 of the function. So if c is a 0 of f of x of any function, then x minus c is a factor of f of x. So in this case, because 1 is our c, and it is a 0, then x minus 1 is a factor, and this is the divisor. Factor means divisor, okay? Factor means it's divisor because, the dividend is divisible by this divisor, okay? So we got x minus 1 times x squared plus 11x plus 228. So we factored f of x. We factored it, but it's not complete factor. We need to complete it, okay? The first factor is okay, is linear. That's fine. However, the second one is not linear. It's a quadratic. So can we factor it? Yes, quadratic is easier to be factored using any technique that you learn. So we have x here, positive 4, positive 7, then you are done. Now we have factored f of x as a product of 3 linear factors. So we answered the first problem. So the factored polynomial of x is factored completely. This is the first answer we got. Then the question says, solve or find the solution of the equation f of x equals 0. So we need to equate this to 0. We need to equate f of x to 0. So this is f of x actually in the factored form. Then equate it to 0. Then use the 0 property because you have a product of 3 linear factors equals 0. Then you can use the 0 property. Or a product of factors equals 0. Then you can use the 0 property. So either x minus 1 is going to be 0, or x plus 4 is going to be 0, or x plus 7 is going to be 0. Solve each of them, you get x equals 1, x equals to the negative 4, x equals to the negative 7. So we've got 3 zeros. 3 zeros. 1, negative 4, negative 7. 1, negative 4, negative 7.